The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. This is Kim Turner with Virtual Management, and this is the kickoff of our second in a series of 3 webinars on standards and open source. I'm very excited for today. Our focus is going to be on what we would call case studies and war stories. So I'm going to give it about a minute or 2 minutes in order to allow a few people to join, and then we'll get started. Welcome everyone to the second of 3 webinars. Once again, my name is Kim Turner and I'm with Virtual Management. I am lucky today to be joined by 3 different panelists, and we will be kicking off our conversation today focusing on what we like to call case studies and war stories. The 3 panelists today I'm really excited about because they're going to be able to bring us some really exciting historical examples and also things that are happening real time in the standards and open source world. One of the themes that we as a management company, and I think our 3 panelists will also talk about today that we're seeing is software as a standard. This theme covers numerous subtopics, legal, governance, membership, tools. All of these things are majorly impacted by this notion that software is now becoming the standard, or that groups want to produce software as the standard. The second theme that I think is important to note that our panelists will also demonstrate is that these issues are not just for one sector or one area of technology. We're starting to see these issues come up across all sectors. We will talk about web, wireless technology, security, IoT, all of those will be covered today. So I'm looking forward to our 3 panelists. I'd like to just do a brief intro to the 3 panelists. We have Michelle Herman, Seth Newberry, and Zaki. Michelle is a return panelist for us. Today, Michelle is really going to focus on some original web standards and standardization efforts around Java. Despite tensions in licensing and development models, both the communities have managed to support one another. And IoT and blockchain technologies are merging these communities in a different way, where standards is not just an implementation of a standard, but rather serves as a standard. Once again, we've got that theme popping up. So Michelle will kick it off and give a brief background, probably spend about 10-12 minutes. And then we'll pop over to Seth, who will share his experience from IoT and telecom space, including real-life scenarios where IoT standards and open source implementations coexist and actually coexist in a functioning manner. So I'm very excited to hear from Seth. And then last, we will hear from Zaki, who is going to talk about security and how security has become an essential concern for technology adoption and some experiences that he has had in the security and standards space. So once again, each of our panelists will talk for about 10, maybe 15 minutes, and then we will open the floor to questions. The best way to ask a question is to put it in the chat window, and I will be able to get those questions and we can open the floor for those questions. So thank you again, everybody, for attending today. With that, I'm going to kick it off and turn it over to Michelle Herman.
Let's see. So hopefully you can see my screen. I'm hoping everyone can see my screen.
Yes. Yes.
Okay, terrific. Okay, well, thank you, Kim, and thanks to Virtual again for hosting this series of webinars. Very brief background about myself. I got involved in standards and open source nearly 20 years ago. I actually started the standards group at Microsoft and managed that group, both the legal and the business parts of that group for a number of years. And then I went into private practice. I was partner at a couple law firms where I managed their standards and open source practices. So I've had experience representing clients who are participating in these communities as well as the communities and the organizations themselves. I recently was also chief counsel at the Invention Science Fund at Intellectual Ventures, which spun off a number of new companies that were incubating new technologies and businesses. And now I have my own law firm, Just Tech Law. So as Kim mentioned, we're seeing this trend, and in particular, open source communities and standards communities are increasingly collaborating on new technical paradigms, if you will. And in doing so, they're trying to meld their processes, their tools, and their IP regimes. It's not always easy to do that. And today I want to highlight some of the challenges, but I also want to point out that it's far from impossible to do that. So what are some of the difficulties? It can be difficult to merge these two kinds of communities because there are fundamental differences in their processes. And actually, there's differences in their objectives, too. Sometimes they're just at odds. So when we think about standards, they're all about conformance. And to a certain extent, there may even be, restraints upon non-conformance in the standards world. While in the open source world, we promote freedom, and that includes freedom to make whatever changes you want, even non-conforming ones. The communities also handle intellectual property rights differently. Software licenses and spec licenses, specification licenses, are actually just different. Software licenses are like product licenses. They extend to whatever's being distributed. But members participating in standards development, they create specifications. So when there's a specification, you have to have a license for the distribution of the specification, but you also have to have some type of commitment for those entities that implement those specifications. In other words, the IP that may be embodied in the implementation, but that's not part of the specification itself. So that means that, members who develop standards have to actually go and, if they want to enforce their IP, then they would have to go and negotiate individual licenses on a bilateral basis with implementers. I think we went too far. Let's see if I can go back. There we go. So standards are developed with the idea that there's going to be lots and lots of implementations, and there'll be competing implementations. The implementations, however, will conform to the specification, but anyone can develop a unique one. The idea is that this spurs innovation by incentivizing entities to develop better ways of doing the same thing, and also can promote diversity in the marketplace by having some standards compliant products that are optimized, say, for different use cases or different technology platforms. So now if the software code itself becomes the approved standard, then we only have one implementation. So this is different than a reference implementation where the reference can be, just an example of an implementation. So here we're talking about a single standard implementation. And that means that there's no other competing implementation. So because of these kinds of concerns, and these kinds of concerns from a legal perspective are antitrust concerns and unfair competition concerns, many standards organizations have policies that restrict or even prohibit the inclusion of software in their specs. So now if the software also happens to be open source software, then we have to layer some additional challenges on top of that. The license for open source software grants all recipients the right to make any changes they want, as we said before, even non-conforming ones. The problem here is that if non-conforming variations gain traction in the marketplace, then use cases could fail and the standards could fail, despite that there's been substantial investment of time and even financial resources, not only by the development community, but by the user community as well. So what can be done to prevent the standard from being forked? Well, Java is a really interesting example. It might be a little extreme, but it's interesting. So most of you are probably familiar with Java, but for those who aren't, Sun developed software, or what we call middleware, to enable application developers to write an application that would run on, any device at any time in any place. But basically, it was operating system neutral. It could run on any operating system, and it did it by providing a set of standard interfaces and making sure that those interfaces weren't modified in a way that an app written for, say, one operating system would then no longer properly function on another. So what Sun did was they provided the development community with specs, reference implementations, test suites, logos, and other IP licenses. And all of them, to get access to all of these things, they required developers to agree essentially not to do things like superset or subset. And what we mean by superset is that you couldn't, say, extend those interfaces to support additional features in your applications, or subset meant you couldn't use a limited set of those interfaces, like, for example, if you're developing for a limited or small footprint device, unless, of course, that subset was something that Sun wanted to standardize, in which case it would make that profile available. So to make sure that you didn't add any feature that, Sun didn't like, Sun could actually control the test suite. So they could actually test for features, and then if the test found that feature in the implementation, they could fail the product as saying it was non-conformant, and the non-conformant products couldn't obtain licenses or the logos. And there's a lot more to this story. I have a blog on some of it if you want more detail. But the point is, this is how you can use IP to, kind of prevent forking. And what's important about this example is it shows it can be done both not only in the software community, but in the standards community as well. So now let's say you layer on sort of the FRAND commitment that standards participants often undertake when they participate in standards development activities, and the expectation of the open source developers, which are often guided by this set of criteria, the open standards requirements. This is something that the open source initiative put out that expresses their view on what would be, how an open standard would be compatible with open source. So as we discussed in more detail in the last webinar, there is a lot of tension between FRAND patent commitments and sort of this notion of you need to have open, unrestricted, royalty-free sublicensing and self-executing licenses for open source compatibility. But even royalty-free standards essential patent licenses can create some considerable tension. So I'm reminded of a proposal that Microsoft submitted to the IETF about 15 years ago. It was called Sender ID. It was one of two competing submissions intended to address email authentication. Before Microsoft had even thought about submitting it, it did sort of what was a common industry practice. If they thought there was something patentable, they filed patents on it. Then they decided to submit it to the IETF, and the IETF requires if you have standards essential patents, you need to disclose them and indicate whether you're going to license. So Microsoft did that. The IETF community became very concerned that Microsoft was going to be charging royalties if you implemented Sender ID. So Microsoft made the commitment royalty-free, but that still wasn't good enough for the open source community. They really wanted Microsoft to waive its patent rights to the Sender ID patents. And that's interesting because even open source licenses, there's not a waiver of IP rights. It is a license. Even many open source licenses have patent licenses right in them. Microsoft didn't waive its rights, but it produced a royalty-free patent license and made all the terms and conditions publicly available so everyone could see them. A number of them were acceptable to the open source community. A number of them weren't acceptable to the open source community. The two that the open source community focused on the most were, the first was that it wasn't sublicensable, it's curious that this is a problem because the license was available to anybody, anywhere, in any chain of distribution. So it's unclear why anybody would need sub-license rights. They also objected strenuously to the notion that you had to actually sign the license if you wanted it. Now, again, you didn't have to sign the license to get the IETF specifications. You didn't have to sign the license to download any software. It was only if you wanted this royalty-free patent license, and that license was made irrevocable. The fact that the license would be there forever was irrevocable. So, but the open source community was so upset about this, they actually did send a letter to the FTC and, complained about these terms, saying they were inconsistent with open source, and asked that the FTC discuss them at their upcoming summit. But the really heart of this story is that before an IETF proposal can become an internet standard, it had to undergo market testing, and there has to be at least 2 independent implementations validated. So after several years, the IETF evaluated the market adoption for these 2 competing email authentication protocols and concluded that there wasn't a strong community deploying or using Sender ID, but there was widespread implementation and deployment for the other competing protocol. But the interesting part about that is the adoption of the competing protocol didn't seem to have much to do with the licensing issues at all after a number of years. It seemed to have everything to do with the fact that Sender ID had compatibility issues with established and pre-existing products. This is just one of many examples that go both ways, where there has been adoption or where there haven't been adoption, where there's been a lot of noise around like licensing and IP regimes between open source and standards. But at the end of the day, they really haven't affected the choices or the actual widespread adoption of a particular standard, and certainly not the ability to do so in open source. Now, where royalties and fees may be involved, I think compromises, as we talked about at the last webinar, probably are needed. But here, the compromises aren't a change necessarily in the business or licensing practices, but rather of the expectations of the parties. And with that, I've probably used my 10 to 12 minutes. So I will feed it over to Seth, and I will take questions at the end. Thanks very much.
Thanks, Michelle.
Hello, everyone. Can you see, is my screen projecting?
Yes, it is.
So my name is Seth Newberry. I am the general manager of the Open Mobile Alliance. And the Open Mobile Alliance is a pretty venerable standards development association that serves the kind of traditional mobile wireless industry. We were formed in mid-2002, just to give you sort of a sense of where we got our start. So we define software enabling protocols, or I should say, we define enabling protocols that are software protocols that allow people to create services on top of those enablers. So things like device management, which is present in almost every mobile phone on the planet, is really widely distributed, and that is an Open Mobile Alliance standard. And the reason that I think our story is interesting is because we started in a time when open source really was not considered particularly interesting to the mobile space, because you had the assumption of super high reliability, 5 nines networks, and you had a cadre of operators, and then they had their vendors. And so this was not kind of the Wild West environment for development that it is today. But now, as we arrive today, we see that the wireless services are essentially a utility. They're as important to the business community as power distribution or water or roads. And every product makes a assumptions that wireless networks will be there in the future. Healthcare products, automotive products, consumer products, everything sort of assumes that there's going to be a wireless network available. And so one of the things that happens is the sheer scale of new requirements is just too big for the operators alone to contemplate and to gate. And also what's happening is that the network layer has started to be virtualized. And so these new NFV virtualized networks are, as they're being developed, they're being driven by open source organizations. And we see that as a really significant trend, because as the lower layers of the stack become open source, we perceive that the higher software layers of the stack are going to become increasingly open source. So where OMA started and OMA protects is a RAND-based organization. Members are required to declare IPR if they submit it into a specification. We have about 200 unique specifications that have about 1,500 or 1,600 patents declared against them. So one of the things that, as a software organization, that we began to find is, as we looked at how do we get more people to develop around our specifications, we found that the talent pool had changed pretty dramatically since 2003. You moved away from this craft-oriented, top-down engineering, where the DMS 100 urban or the 5E switches were important, to much more of a DevOps kind of compute-oriented model. And now we see that we have really geographically diverse pools of contributors. They're managing these code builds with GitHub and Slack and a whole series of other open source tools which change on a daily basis. And they are increasingly deploying open source into the networks, either directly into the networks or sometimes through other vendors. So our challenge, and one of the things that we tried to figure out how to deal with, was the fact that as a standards development organization, we produce a big old PDF. It's 400 or 500 pages long. And we actually went out and started talking to developers and watched them try to implement our specs. And the developers just flat out hate what we produce. Back when you had 15 or 20 companies that were producing in their own labs these enablers, or using these enablers, it was fine, because all of the people who were building applications were also developing the specs. But as that market began to collapse and you began to see more independent developers, that model went away. So we see that developers have a whole set of unique needs. They need things like test events or hackathons. They need the source code. They need a forum where they can discuss, hey, how does this work, and what did you do here, and if I bootstrap this, what happens, and so forth. And they also need sort of a testing infrastructure that they can come in and try out their implementations on. So the model on the right hand of the screen here is really much more of a kind of a compute-oriented model than ever used to exist in the telco space. So what OMA had to figure out how to do was to bridge that gap. And we started creating a set of tools that we thought would help us. And I'm going to give a little war story about which tool and what we did in a minute. One of the things that we also recognize is that as a software standards organization, we were really exposed to open source. It was taking away, if you will, work that could have been done at OMA. And we wanted to find out how our constituency was reacting to this change in as open source. So we did a survey that was pretty well conducted. We had a good sized response group. And so the first thing we did in the survey was just to make sure that everybody had definitions that were standard, because we actually do find that while open source has a bunch of definitions, the difference between open source and open standards is not always clear in people's mind. And so what first thing we did is we just said, what is an open standard? And the document that's sitting in front of you is 99% of the respondents agreed that this is a good definition for open standards. And I won't read it because most of the people here are probably pretty clear on it, but it gave us a baseline. And definition of terms, I think, for executive directors in particular is a really important thing. Then we also talked about what open source projects, how those were defined. And we used this definition just as, and I think Michelle gave us plenty of detail on what an open source program was like and how it's defined. And we got good, solid agreement that yes, this is, we agreed this is about right. So we, at least when we surveyed, we knew that we had the terms pretty well defined. So then we asked the people, and these are, again, predominantly telecom-oriented people, how you characterize your participation in these organizations. And we were quite surprised to see that at least 41% of them were actively making contributions or pull requests to a code base. And that's a lot for the companies that we were talking to. It surprised us how much there were. And another 37% said that they were actively monitoring the progress of the code base. They went into the repositories and they were looking at what was there and they were seeing how they wanted to deal with it. Then a smaller bunch participated sort of at a strategic level, but they weren't operational, and very small did not participate at all. And then we asked them, sort of a trend of their participation. And we found that more and more of our members, over 57% said their participation would increase. 29% said it would be steady, and 2% said it would decrease, and 12% just weren't sure. So by and large, we got a sense of up and to the right, active membership participating in open source projects. So then we asked the question of our telecom services people what they thought would be the dominant trend in the next several years relative to open standards and open source. And the question we asked were 4 questions. Would proprietary implementations of non-standard specifications be the rule? Would proprietary implementations of open standard specifications be the rule? Would open source implementations of open standards be the rule, or would open source implementations not using open standards, which would just be essentially open source code only, be the rule? The response that we got was really interesting. This was by and large the largest group, which said open source implementations of open standard specifications would be the dominant trend over the next several years. So we found that interesting because they're right. These are a little bit different. How do I do an open source implementation of an open standard which may have RAND in it? And when we said, do you believe RAND-based specifications can be successfully implemented into open source? You got what I think would be a pretty typical response was, we don't know how you're going to do that. We think that it's important. We think that it's the dominant trend, but we don't know mechanically how that's going to happen. 60% said they weren't sure how it was going to happen, and 36% said, yeah, it will happen. And only 4% said, no, that won't happen. So you have, I think, what's interesting in this slide is that you can see there's a clear demand for people bringing open standards specifications into open source implementations. There's real demand for it, and there's also real confusion about how it can be done. So the questions we're asking here are actually quite appropriate. The complexity and incompatibility of licensing terms was, in the written comments, was cited quite frequently as the biggest hurdle. So let me tell you OMA's story about this. So in the course of our normal business, we developed a transport protocol that's optimized for constrained devices in the IoT space that became really popular. And one of the reasons it became popular is because we deployed some of the tools that we were talking about. As a standards group, we deployed a developer toolkit. We showed source code. We gave people, we posted a lot of our information on the GitHub repositories as opposed to in more proprietary fashions like our historically historical association would have done. We consciously opened ourselves up to the developer community, whether they were members or not. And the developers took notice of this, and several open source lightweight M2M implementations were developed. A couple of the most popular ones were developed at the Eclipse Foundation, which is, they happen to be called liaison and Wakama. And the followers grew. People liked it, and it's a very popular specification in the IoT space. However, what happens is that later, some claims of essential IPR were filed on lightweight M2M. And so this of course runs counter to the Eclipse license. But the developer interest continued to grow, and so we were working with Eclipse, and we really like the Eclipse guys. We think what they're doing is great, but attention began to grow because this was sort of outside the range, the normal range of what Eclipse did. And I think at the same time, Eclipse recognized that this kind of open source implementation of RAND specifications was still worth doing. And so we've begun to see other Eclipse projects growing out of other RAND specifications. So a big contributor to the IoT specifications is 1M2M. And that is creating the Eclipse OM2M project. And so there's really significant pressure to create some cooperation agreements. And one of the other problems is that the specification groups want to have cooperation agreements, and they want to be able to normatively reference between open source and RAND specifications. And so that too is a difficult bridge to cross, simply because if an open source entity normatively references a RAND specification, essentially that RAND gets dropped into the open source implementation, and that turns into a problem. So, but we see the desire for these guys to work together on this in order to move forward effectively on producing products for the market. So I see a couple of trends emerging. How's my time? I see a couple of trends emerging. So do I need to stop?
Well, I don't necessarily know that stop, but I think you've got some key takeaways. So if you wouldn't mind going into those real quick, and I think we can revisit some of your topics as well.
All right. Sorry for running along here. So the things that we're seeing is the RAND-Z community is not seeking compromise with the RAND community. But what the RAND community is trying to do is to allow some of their supporting documents, the ones that are specific to developers, to be classified with liberal copyright terms, like BSD. And some associations are installing RAND-Z options into RAND associations that effectively allow a work item to be developed under the open source. Oasis is a really good example of that. And it's only time to tell if these compromises are effective, because at the end of the day, these obligations still exist. So one couple of takeaways I would say, if you're an executive director, when you're working through open source in your RAND organization, be incredibly precise with terminology, because we've used the term open source, but open source doesn't always mean free software, although most people think it means free software. And so you'll get into a semantic argument with your directors very quickly on this. So really be precise. Keep the distinction between open source code and specifications that are open source very clear, because the open source code is actually pretty simple and pretty well defined, but standards that allow unencumbered implementations to be created out of those standards is really much more of a disclosure and rule setting nature for the working group. So you've got to make sure that anybody who contributes has to assert that it's either open source or free, or they non-assert their IPR rights or something. And that's the piece that's quite important. And also just recognize it's really hard to teach an old dog new tricks. RAND associations have this legacy of these protected IPR rights, and they're very difficult to give up. And it's very difficult to commingle them. So be cautious there. And also, when you go down the open source route, open source means tools. So there's a lot of stuff that the open source community uses that the RAND community doesn't in terms of developing the specs. and you got to be familiar with those. You know, GitHub, Atlassian, Slack, all of those things need to be adapted for the purpose of writing specifications if you want to engage open source contributors. And I'm going to let this last slide go. It's just a couple of things that we've done, but since I overstayed my my reservation here.
Thank you so much, Seth. And like I said, I think there's some topics we can revisit in the question and answer section. But I think this is a great intro into Zaki as well, and that, you know, his experience in the realm of security and some of the problems that he has seen with regards to specifications, and in particular legacy specifications. So Zaki, I'm going to go ahead and turn it over to you.
Okay, so just quickly a little bit about myself. I'm the executive director of a brand new consortium. We're called the Trusted IoT Alliance. We operate at the sort of intersection between blockchain and Internet of Things. And in general, the blockchain space is sort of a pre-standard space. There's a lot of open source software. Almost everything in blockchain is open source. Some of it just has to be from the nature of the technical implementation. But we're still very early in the days of standards. And I'm also sort of a very non-traditional background to be executive director of an organization like this. I'm primarily a technologist. I write a lot. I've in the past written a lot of code. I'm an expert in cryptography. I'm an expert in security. And I don't know, I found myself in this unique position of trying to sort of create collaboration and cooperation across the blockchain space. But sort of what I wanted to focus on in just talking to you all is, I guess it's probably less obvious to people who don't live and breathe security. But this 2017 has definitely been like a pretty eventful year in the way standards and security have intersected with themselves. And so there's often been this attitude in sort of the general software development community that security is just a feature of software, and you develop it like every other feature. And then there are security people like myself who think that security is special. It's special because there's an adversary, and that adversary is trying to break your system. Unlike many other things where you might have bugs, and those bugs might impair functionality, or you might get things wrong in the specification that might have to be revised. If there's a security flaw in your software and it gets built into 1 billion IoT devices, that security flaw may be there for the next 20 to 40 years or longer. So we look at, I tend to view security as kind of this special domain, and security is the entire point of blockchains. And so I think in the blockchain space, specific to our org, I'm trying to find ways of being a change agent and doing things differently. But we also need to look, I kind of want to increase awareness in the standards community. So standards are really important for security. Standards are important to any protocol that's going to do authorization or confidentiality in the protocol. So any sort of transport, any sort of application protocol, security is always there. Another thing that we see in security is that new advances in cryptography are frequently poorly adopted until they make it into a standard. There's often a misleading sense that once something's standardized, it means the experts have looked at it. And sometimes that's true, and sometimes it's not so true. Security is also, so standards are also, and standards and intellectual property rights are also like, there's a 30-year history that I could talk to you for probably hours about just like all of the historical sort of mistakes and pratfalls and disasters that we have found ourselves in because the wrong kind of intellectual property was applied to a piece of cryptography, and the thing that was most secure wasn't adopted because there was something else with less IPR around it that was available that seemed to be good enough. And then years later, it was realized that it wasn't quite so good. So this is just a block. Well, it's an excerpt from a blog post from Matthew D. Green, who's a professor of computer science and cryptography at Johns Hopkins, and probably like my favorite academic offensive security person in the entire world. And so he's come up with this great strategy for getting his grad students to find papers. And this strategy is he purchases, he goes to like the IEEE and other standards bodies, and gets access to all of the standards and certification documents for various devices and the standards that they're following, and then he assigns a grad student to read them until they find something that is obviously disastrous for a widely deployed piece of security technology, and then they publish about it. And this strategy in 2017 seems to be working really well. There have been a lot of really high scale a lot of really high-scale disasters. So the encryption devices from companies like Fortis that are used by banks and governments for their VPNs turned out to be trivially interceptable because of flaws in the encryption standards that they all implement. Wi-Fi passwords. So there was an attack called Crack, which got a logo and was fairly widely publicized. Basically means that that you typing in your password for your WPA to Wi-Fi security probably does nothing at this point, and probably will never do anything ever again, because while it is fixable, deploying that fix has been really hard. And another example has been the national ID cards of Spain and Estonia, which went through a certification process that the cryptography key generation on those cards went through. Was like sort of a white box security process with the National Institute of Standards in the United States, and sort of certified that their software complied with the specification, turned out to be flawed, and now we have national ID cards that are used for unimportant things like elections that are vulnerable. So in general, things have been going, and like these are the themes. Like it's like, if you read the standard, a cryptographer would look at it and say, surely you're joking that you did this, that making a grad student read every FIPS document in the CMPB website is a viable strategy for finding things that are publishable and newsworthy in terms of security flaws. And things get missed for a really long time because of closed door process around security, because we do the things that like have worked really well for standards organizations in lots of other domains, but don't work so well in security, like doing closed door processes, having paywalled specification documents so that the standards body can make some revenue from it, having like patents and reasonable patent disclosure terms around some of the security standards. All of these things seem to sort of be a recipe for disasters. So here are the kind of the things that I'm trying to communicate to my members in terms of blockchain and my constituents in terms of doing things better. Security is probably the worst place to try and build up a sizable intellectual property portfolio, especially if that intellectual property portfolio is something you want to have standardized. The more IPR, we have a long history of the software industry being willing to trade weaker security for less intellectual property rights. In general, they will just not adopt a thing if there's a company that is trying to establish a strong business around that. The other thing is curious people on the internet are a really important resource for getting security right and standards. But it's also really important to signal to the wider security community when you're going to become an industry standard, and you might put it in, and the standard might end up being millions or billions of devices, or millions and billions of dollars might ride on top of it. Because yes, random people from the internet may wander in and find important flaws, and trying to encourage that is really important. And you can use open source and hackathons and bug bounties and all that stuff to do that. But also, you can if you tell the wider security community that you're in the process of doing something that might be really important, they may end up, more people might find it valuable to pay attention. And that kind of communication tends not to go super well, but I'm trying to make it better. So that is is what I wanted to tell you about today, and back to Elizabeth and Kim.
Thank you so much, Zaki, and to Seth and Michelle. We've had a couple of questions come in, and I think there was one really important question about forking, and I think I want to pose two different questions. And the first one, I think, Michelle, you might be best to describe what we mean when we say forking. But I think a follow-on to forking is, whether or not the forking of either code or a standard is troublesome for an industry or a community that thrives on interoperability. And I would love to hear from all three of you on that. But Michelle, maybe you could, do a quick description of what we mean when we say forking.
Yeah, sure, Kim. Well, at least what I mean by forking is that in the context of, well, either standard in terms of a stack, or what people talk about is like a standard software distribution, where changes are made to it so that it no longer, if it's implemented in one product and now the modified version's implemented in another, they don't actually interoperate. So when you have multiple variations out there, and particularly variations that actually gain traction in the market, that can actually divide the market, which is somewhat opposed to what we're trying to do with standardization, whether it's through software, a standard software distribution, or a standard in terms of the spec. So that can be seen as very problematic, especially if both the development and the user community has invested a lot of resources, behind one standard version. So hopefully that answers the question about what is forking. And then Kim, remind me what the follow-up was.
Well, I think you hit on some of it in the sense that, wanting to hear from all three of you on whether or not, in an industry that thrives on interoperability, is this forking troublesome? Or maybe, perhaps Zaki or Seth, you have an example where forking didn't happen, because you kind of went about it at in a different way within some of the groups that you're involved in.
Well, this is Seth. I can tell you that the standards guys they do try to avoid forking because it does complicate things. They tend to try to keep everything backward compatible up to certain levels. But on occasion they will deprecate a specification and create what's effectively a fork. And there's a couple of ways of handling it. Number one is you just live with the fork. And I think that's really context dependent upon, how deeply buried this piece of technology is. The other one is that sometimes you can fork and retain interoperability, but you don't retain compliance. And so, the conformance or compliance is usually a much more line by line kind of test that says you do exactly what inside your black box, each line conforms to the way the specification is written, compared to interoperability testing, where you just make sure that the edges of the black box give and receive the same sorts of information that they're supposed to in the specification. So, and I do think that forking is a highly experimental kind of thing that we're seeing a lot of in open source. That is another reason why open source is a little bit of a difficult one for the telecom industry, simply because they really are very, they view continuity with great affection.
Yes, I would very much agree with that last statement. Zaki, I'd like to turn it over to you and see if this is a phenomenon that you've experienced or seen, or perhaps, yeah.
Yeah, so forking is like, I don't know. So you may have, we've gotten to the point where forks in blockchains can be national news or international news, especially it's international business news. So like stakes have gotten really high in our space. And what we've been starting to, but what I basically view forks in all of my software experience are basically are part of like the political economy of open source software. It's a mechanism by which people are trying to obtain and exert power in a system of software. So you see threatening to fork enormously, and it is interesting to see how there are two approaches that can both be advantageous for a group that wants to create political power. One is to fork and sort of divide the ecosystem because they want to create they want to separate the ecosystem into competing pieces, probably one where them and their collaborators have more power and they're able to potentially overwhelm or defeat or at least coexist with the fork. There's the other side of it, which is where people want where people will want to fork software because and then retain compatibility, but give them their own sort of version of that software that they're able to drive changes, add new features to, etc. And sort of so you have two things that are compatible but have two versions of governance. Then you have the forking model, which is you have two incompatible things that have two different models of governance. And that's like the common pattern I see throughout the world. And it's just basically really important for people to understand that, like, while there's all this technical jargon and there's a lot of detail around forking, at the end of the day, forks are always about politics and they're always about power.
Thank you for that. I think that it's an important piece, especially for standards groups that have been around and worried about contamination for any of their legacy specifications. But how do they also adopt into this converging open source and standards so I think your final comment, Zaki, really goes to, kind of what's the basis for, why people are getting together and what you're creating. And, do we end up in this space where the software becomes a standard? I'd like to kind of turn a little bit towards, some of the topics that, Michelle, you and Seth both touched on too about license compatibility. Seth, I think you maybe had a couple other comments you probably could have made about the, kind of the RAND environment and how that, equates to the open source environment. But, maybe to you too, Michelle, kind of the Java license, whether it's, considered complementary to FRAND or whether or not it's consistent with open source licensing. So if, Michelle, if you wouldn't mind maybe going into a little bit about the complementary or maybe lack of complementary terms between the Java license and the OSS world.
Yeah, sure. If we look at the Java licensing regime, and I think to Zaki's point that forking, is about power and politics. It's always, in my experience, about developing preferential implementations for a certain technology platform, a certain set of vendors, or and that's why it's done. There is a lot of pressure in the community to maintain interoperability, but if you use a regime like Sun did with Java, which includes a whole series of different agreements with these restraints on them, particularly around the testing, it seems to me that it's hard to say that something like that would be consistent with a RAND or FRAND regime. Although I will say this, Sun did submit, subsets of Java to a number of standards organizations, and a number of them did consider them RAND. But at the same time, I don't think that the open source, there was also a lot of concern from the open source community when Sun made versions of Java available under the GPL, because Sun still controlled the test suite. And so they were doing it for legitimate reasons to control forking. However, it wasn't consistent with the notion of our open source developers to be able to change the code any way they wanted. And if you wanted to do a Java-based implementation in a product, you couldn't get the logo unless you took the license to the test suite, and you couldn't pass the test if you did anything that Sun didn't approve of. So there was a lot of concern both in the open source community and in the standards community about those licenses.
Thanks, Michelle. Seth, I don't know if you had any more that you wanted to add about, the complications that OMA saw with a RAND environment, and I think you did make a good point already about making sure that everybody's on the same page about terminology and what open source means. Sometimes it doesn't always mean that it's free. Do you have any other items that maybe you wanted to share on that topic?
Yeah, I think the one thing that, again, if you're an executive director and you're thinking about moving from RAND to an open source environment, and you've got people who are, very much engaged in the RAND, their business model lives and breathes around RAND. These guys have some very nuanced and very sophisticated perspectives around what an open source license actually gives you in the long run. And the problem with that is that if you were contemplating going into an open source model or having one, what you're really trying to do is you're trying to get engagement from a broader range of companies. So, every standards development organization lives and dies on its contributions, right? What spec are we working on? How many people are working on it? And are the people who are working on it important to the industry? And so by adding an open source angle, you at least in theory have the ability to attract a broader group of people into the specification. So that's a good thing. But most of those new people you're going to bring in are not going to necessarily be sophisticated in the terms and conditions of what open source licenses really truly mean. And there'll be a few of them that are. And so you got to be really careful, because it does become important, because the problems that a standards association will run into down the road are going to be some kind of an infringement problem, some kind of you didn't tell us that this wasn't open source, or you didn't tell us that this was encumbered by licenses. And so your duties as an executive director are kind of to make sure that the playing field stays level. And that is getting more difficult, I find, because there are some pretty sophisticated arguments out there about, where open source stops and starts. And at that point, I stopped pontificating, and I turned to somebody like Michelle, who actually has a law degree and probably knows. But that's been our experience.
Yeah, and we just have a couple more minutes left, and Zaki, I think both you and Seth kind of touched on this notion that kind of the membership, or how a lot of us traditionally think of membership, is also changing. Zaki, you'd mentioned that there's a lot of super creative people out there that want to assist in the development of security. And Seth, I know you also mentioned that you need to have hackathons and some other things that bring in a different kind of member. So I think maybe there's 30 seconds or so to kind of maybe have a takeaway on the type of people that you want to develop these new technologies. So Zaki, I don't know if you have any quick feedback on that piece.
I mean, I think it's mostly the understanding of that, like there is community, that like software engineering is definitely, like, my experience of it is that there is in most of these softwares, there's a community that is bigger than a company, and where the primary actors in this community are not people who are associated with companies, but people who kind of have their own sort of independent portfolios. sort of successful products like attract their attention and are able to encourage them to work on it. And sometimes that's facilitated by them being hired by a company, and sometimes that's not. And if you don't have sort of mechanisms for sort of non-traditional or contributions, you can end up without the expertise of people who have significant expertise to contribute.
Yeah, I think that's an excellent point. Well, we're right at the 2 o'clock / 11 o'clock. Seth, I don't know if you had 10, 15 seconds. Nope. Okay.
Nope.
Okay. So thank you to our 3 panelists today. And I realize, we just had an hour and there's probably so much more to talk about. But this continues to be a really interesting area with a lot of new ideas and new ways of doing things, and certainly listening to your community and understanding what your membership looks like, and understanding what both the membership and the industry are asking for, and how we're trying to get these 2 types of communities to work together. And I think all 3 of our panelists have given at least a couple of highlights on how they're working through these issues, and how we're hoping to come up with some solutions. So thank you again to all of our panelists. And once again, this was our second of 3, and our next webinar is in a couple weeks in December, where we hope to kind of tie up the conversations that we had and start focusing on some next steps. Thank you, everyone, today.